Let's discuss exponential equations. Exponential equations have the variables in the exponent. That, for example, we have 2 to the power x is equal to 16. The variable or the unknown x is the exponent. That's how you recognize, or that's how you identify exponential equations. So the way we solve exponential equations is a bit different from the way we solve other algebraic equations. You will see how. To solve exponential equations, use the laws of exponents. We express each side of the equation as a single power with a common base. Remember, an equation has got two sides, which is the left-hand side and the right-hand side. So it means the left-hand side must be a single power, and the right-hand side must be a single power. Remember what a power is. Like, for example, if we have 2 to the power x is equal to 2 to the power 2. You see that? We have a single power this side on the left-hand side and a single power on the right-hand side. And then these single powers must have a common base. When you're solving exponential equations, express each side of the equation as a single power with a common base. The base for the power on the left-hand side must be the same as the base of the power on the right-hand side. Using our example, we may have this, you see that 2 to the power x is equal to 16. Now we write 16 as a power. So we have 2 to the power x is equal to 2 to the power 4. Note this. Note this. You see that the bases are different here. The bases of the powers must be the same. If the bases are equal, what do we do then? We equate the exponents and solve for the unknown. Like here, the base here is 2, the base here is 2. Therefore, the exponents are equal. Therefore, x is equal to 4. If the bases are equal, then the exponents are equal. If a to the power x is equal to a to the power y, therefore x is equal to y. Again, there's this one. If the exponents are equal, we equate the bases. Please remember this. On this tutorial, we're going to concentrate on this one, where the bases are equal and we're equating the exponents. If the bases are equal, then exponents are equal. And if the exponents are equal, then the bases are equal. Let's check examples. We're solving for x. We must have a single power on the left-hand side and a single power on the right-hand side. 27 is written as a power. Is 3 to the power x is equal to 3 to the power 3. Now the bases are equal. We can say therefore x is equal to 3. We're solving for x here. We have single powers on the left-hand side of the equation and right-hand side of the equation. But what is the problem here? The bases are not the same. So let's make the bases to be the same. 8 is 2 to the power 3. Then x plus 3 is equal to 2 to the power 2. Then 3x plus 2. See that? And then we use the law of exponent, raising a power to a power. A to the power x to the power y is equal to a to the power xy. Remember that, raising a power to a power, we multiply the exponents. So we multiply. Please distribute the 3. 3 times x, 3 times 3. Then here 2 times 3x, 2 times 2. So we get 2 to the power 3x plus 9 is equal to 2 to the power 6x plus 4. The powers have the same base, so we can equate the exponents. Therefore, 3x plus 9 is equal to 6x plus 4. Then we solve for x. We can say 3x minus 6x is equal to 4 minus 9. And then 3x minus 6x, that is negative 3x. is equal to 4 minus 9, that is negative 5. And then we divide by negative 3 on both sides of the equation. X is equal to 5 over 3. Again, we have to make sure that we have a single power on the left hand side and a single power on the right hand side. So what we do, we have 4 to the power 2x is equal to 1 over 4 squared. 16 is 4 squared. And then remember that 1 over x to the power n is equal to x to the power negative n. So it's 4 to the power 2x is equal to 4 to the power negative 2. Now the bases are equal, so we can equate the exponents. Therefore, 2x is equal to negative 2. Then divide by 2 on both sides of the equation. X is equal to negative 1. But most of the times when you're dealing with exponents, we say that our bases must be prime. So we can also do that. And then let me deal with this one here at this level. So 4 is 2 to the power 2. Then 2x is equal to 2 to the power 2. And then negative 2. Okay. So 2 times 2x, that is 4x. So 2 to the power 4x is equal to 2 to the power negative 4. Therefore, 4x is equal to negative 4. X is equal to negative 1. See that? Getting the same answer. Let's deal with this one. Okay, we must have a single power on the left hand side and a single power on the right hand side. Now the problem here, there's a coefficient here, 3. So what do we do with this coefficient? We want a single power. A power must be just a base and an exponent, not a coefficient. So how do we get rid of this coefficient? We have to divide by it on both sides of the equation. So it's 3, then 4 to the power x is equal to 192. Divide by 3, divide by 3. So 3 divided by 3 is 1. So we remain with 4 to the power x is equal to 64. 64 is 4 to the power 3. So you can say 4 to the power x is equal to 4 to the power 3. Now we have a single power this side, single power this side. The bases are the same. Therefore, x is equal to 3. Let's say you decide to use prime bases here. 4 is 2 to the power 2 power x. 64 is 2 to the power 6. This is 2 times x here is 2 to the power 2x is equal to 2 to the power 6. Therefore, 2x is equal to 6. Therefore, x is equal to 3. We're getting the same answer. How do we deal with this one? We have a single power this side. We have 1 this side. How can we convert 1 to a power with a base of 9? Any base to the power 0 is equal to 1. We can have 9 to the power 1. 9x plus 4 is equal to 9 to the power 0. Now we have a single power this side and a single power this side. The bases are the same, so we can say, therefore, x plus 4 is equal to 0. And then subtract 4 from both sides of the equation. X is equal to negative 4. Even if you convert these to their prime bases, you get the same answer. 9 is 3 squared. Then x plus 4 is equal to 3 squared to the power 0. 2 times 0 is 0. So we have 3 to the power 2x plus 8 is equal to 3 to the power 0. 2x plus 8 is equal to 0. Then 2x is equal to negative 8. Therefore, x is equal to negative 4. The next one, we have a single power this side, a decimal number this side. So how can you write this as a power? We have to write this as a fraction first. So it's 2 to the power x is equal to 25 over 100. It's very easy to write a decimal number like this as a fraction. The denominator is always what? A power of 10. So the number of decimal places is equivalent to the number of zeros. So if it is maybe 0, 125. There are how many numbers? 1, 2, 3. So it becomes 125 over how many zeros? So it should be 3. 1000, something like that. Very easy. And then this is simplified to 1 over 4 is equal to 1 over 4. And then 2 to the power x is equal to 1 over 2 squared. And remember, 1 over x to the power n is equal to x to the power negative n. So it means 2 to the power x is equal to 2 to the power is equal to 2 to the power negative 2. Therefore, x is equal to negative 2. And we have this one. We don't have a single power this side on the left hand side, so we have to combine this. Let's start by writing these bases as products of their prime factors. 16 is 2 to the power 4, then to the power x times 4 is 2 to the power 2 to the power 2x is equal to 1 over 2 squared. Raising a power to a power, we multiply exponents. 2 to the power 4x times 2 to the power 4x is equal to 2 to the power negative 2. And then here, we're multiplying powers with the same base, so we add exponents. So it's going to be 2 to the power 4x plus 4x is equal to 2 to the power negative 2. 2 to the power 8x is equal to 2 to the power negative 2. Therefore, 8x is equal to negative 2. Then we divide by 8 on both sides of the equation. X is equal to negative 1 over 4. Right, we want single power on the left hand side and single power on the right hand side. We have coefficient 4 here, so how can we simplify this? 4 is 2 to the power 2. It's always safe to write your bases as products of their prime factors. So it's 2 to the power 2 times 2 to the power x is equal to 0, 0.5. I said that there's one decimal place here, so it's 5 over 10, isn't it? Which is 1 over 2. So this is like 1 over 2 to the power x minus 2. Here we're multiplying powers with the same base, so we add exponents. So it's 2 to the power 2 plus x is equal to 2 to the power negative 1, and then x minus 2. Then we're distributing negative 1 here. We're multiplying by negative 1. So it becomes 2 to the power 2 plus x is equal to 2. And then negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Now the bases are equal. We can equate the exponents. Therefore, 2 plus x is equal to negative x plus 2. Bring the x this side, becomes 2x is equal to 2 minus 2 is 0. Therefore, x is equal to 0. Let's check that. Let's check. Let's use this part. Maybe which part is easier to use. Maybe let's use this part. I want to check if the answer is correct. So it's going to be 2 times 2 plus 0 is equal to 2, negative 1, and then 0 minus 2. And then 0 minus 2 is negative 2. So it becomes 2 to the power 2 is equal to 2 to the power negative 1 times negative 2, that's negative 2. Okay, yes, our answer is x is equal to 0. Let's do the last one. All right, let's write our bases as products of their prime factors. And then 4 is 2 to the power 2. 9 is 3 squared. So we say 2 to the power 2 power x minus 3 to the power 2 over 3 to the power x plus 3 is equal to 29. Remember, multiplication is commutative. I can write this as 2 to the power, because 2 times x and x times 2 is just the same thing. Then minus 3 squared over 2 to the power x plus 3 is equal to 29. If you check here, this is difference of 2 squares. The numerator, there is difference of 2 squares. So it's 2 to the power x minus 3, 2 to the power x plus 3 over 2 to the power x plus 3 is equal to 29. 2 to the power x plus 3 divided by 2 to the power x plus 3 is 1. So we remain with 2 to the power x minus 3 is equal to 29. We want the single power on the left-hand side and the single power on the right-hand side. So add 3 on both sides of the equation. 2 to the power x is equal to 32. 32 is 2 to the power 5. 2 to the power x is equal to 2 to the power 5. Therefore, x is equal to 5.